Hello guys, welcome back to mathematics. Today we are going to check the classification of the real numbers. So let's start talking about what are real numbers. So basically the real numbers were called just numbers before the complex numbers. So all the numbers divided in two groups, the real numbers and the complex numbers. The complex numbers are a result of taking the square root of -1. As you know, a negative number has no root, because if you multiply to the square a positive number, you get positive, and a negative number, you also get positive, so you never get a negative. So they call this square root of -1 as I, or sometimes J. You can see it like this. The I stands for imaginary numbers. So this complex number has like very specific applications, so we don't have to worry about them yet. We are just going to talk about the real numbers. Then the real numbers is every number that you could think of. It could be the 1, 100, 1/4, square root of 5, pi, Euler number 1.2357, etc. They are all real numbers, but they classify in different groups according with their characteristics. Let's check. The first group we are going to check is the natural numbers and whole numbers. They are pretty similar. They are just the ones that we use to count. So we are going to use 0, 1, 2, 3, 4, 5. As the name itself of the whole numbers, they represent entire units. They are not gonna represent parts. And what's the difference between natural numbers and whole numbers? It's just that the natural numbers don't include the 0. So all of these ones are natural numbers if we don't include the 0. And if we include the 0, we would be talking about the whole numbers. The n is the symbol of the natural numbers. They always have this special double line just to represent that we are talking about all the group of natural numbers. So just as the real numbers, that they had like a double line to identify that we are talking about a group of numbers. The whole numbers, they don't have a symbol because they are pretty much the natural number, just including the 0. The next groups are the integers. The integers are represented with the symbol of a z. And they are also going to represent the integers include the whole numbers 0, 1, 2, 3, 4, etc. But it also includes the negative numbers -1, -2, -3, -4, etc. But notice that they are also complete units. We don't have parts. We are not breaking the unit. Those are the integers. So you have positive and negative integers. The positive integers are going to be the natural numbers. And finally, we have this division between rational and irrational numbers. The rational are represented with a Q and the irrational with an I. The rational numbers are basically any number that you could express it as a fraction. So for example, the natural numbers like 5, you could represent it as a fraction because you could write 5/1. Or some decimals like 2.5, you could represent it as 5 divided by 2. All the fractions themselves are going to be also rational numbers. And of course the percentages. There are also decimals with a lot of decimal places that they can always be converted into a rational number. It doesn't matter if they have a lot of decimal digits. You can always represent it as a fraction. In contrast, the irrational number cannot be expressed as a fraction. The typical examples here are the pi number, the Euler number, and some of them square roots like square root of 2 or square root of 5. You are going to find that they have a lot of decimals and you cannot really express it as a fraction. They are called the irrational numbers. Okay guys, so taking in account just the real numbers, we would have two groups, the rational and the irrational. The irrational, remember, is like pi, Euler number, the square root of 2, the square root of 5, that kind of numbers. Infinite decimals without repetition, without any pattern. And then the rational that we could express as fractions. So it could be fractions themselves or just decimals that we can express as a fraction even when they have a lot of decimal spaces. They are all going to be rational numbers. In the rational, we also have the integers. They are going to be all positive and negative numbers that include the whole numbers and the natural numbers here inside here. So we would have 1, 2, 3, or 100. They are just examples, 5,000. In the whole, that they are not included in the natural, we are just going to have the 0. And in the integers that they are not included in the whole, we are going to have the negative numbers. It's 1,000 minus 25. Notice that the naturals are inside the whole, which are inside the integers. So we could say that 105,000, they are also integers. So this is like a map about the needs of the human. Like at the beginning, we just needed to count things. So they didn't even have the 0. They didn't need it at the beginning. They were just considering something until it exists. So the first number would be 1. It was just after a lot of years that they started to create a symbol for the 0 and the need of having it in the account. And then the negative talk about depths, temperature, a lot of stuff that we need with the negative numbers. And then the rational, that they are going to be to administrate parts of a whole. And then the rational, with the development of a calculus and geometry, they started to talk about the irrational numbers. And notice that after that, the complex numbers, that they have very specific applications. So it's very interesting how this diagram of real numbers is actually a map about the use of the numbers in this story. Okay guys, that was all for this video. Don't forget to subscribe, book your own lessons with me if you want, and drop any questions you have in the comment box. Bye bye guys, see you next time.